Scattered across the galaxy, there are planets drifting alone in the darkness, completely unattached to any star. Unlike Earth, which orbits the Sun, these rogue planets wander through space, with no light, no warmth, and no solar system to call home. For decades, scientists believed that planets could only exist within star systems, forming alongside their parent stars. But rogue planets defy that idea, floating freely through the universe, unseen and mysterious. So how did these planets become lost in space? Were they formed this way, or were they violently ejected from their homes? And could one of them ever drift into our own solar system? Most planets we know of orbit a star, bound by gravity in a stable solar system. But rogue planets are different. They drift aimlessly through space, with no sun to warm them, no orbit to follow, and no home of their own. Unlike stars, rogue planets don't emit their own light, making them nearly impossible to detect. The only way scientists can find them is through gravitational microlensing, a phenomenon where a rogue planet bends and magnifies the light of a distant star as it passes in front of it. What makes these planets so strange is that they shouldn't exist in large numbers, yet they seem to be incredibly common. Some studies suggest that for every star in the galaxy, there could be at least one rogue planet wandering freely through space. That means billions, maybe even trillions of these lost worlds could be out there right now. But if rogue planets don't belong to a solar system, where did they come from? Were they always alone? Or did something throw them out of orbit and into the darkness? If most planets form inside star systems, then how do some of them end up wandering through space alone? Scientists believe that rogue planets were not always rogue. Many of them likely started in a solar system, just like Earth, before being violently ejected. One of the leading theories is gravitational instability. In a young solar system, planets are still forming, competing for space and influence. If a massive planet, like Jupiter, forms too close to a smaller one, its powerful gravity can send the smaller planet flying into deep space. This can happen when two large planets interact, or when a passing star disrupts the delicate balance of a solar system. Another possibility is stellar evolution. When a star dies, it can go supernova, losing much of its mass in a violent explosion. The sudden loss of gravity can loosen a planet's orbit so much that it escapes entirely, turning into a rogue world. Some scientists also speculate that rogue planets might form alone, without a parent star. If a dense region of gas and dust collapses on its own, it might create a planet without enough mass to ignite as a star. This is rare, but it could explain why some rogue planets appear to be extremely large. However they formed, one thing is clear: rogue planets are everywhere. But how many are there, and could some be closer to us than we think? For a long time, rogue planets were thought to be extremely rare, but recent discoveries suggest they might be shockingly common. Some studies estimate that for every star in the galaxy, there could be at least one rogue planet, meaning there could be billions, if not trillions, of these wandering worlds drifting through space. The best evidence comes from gravitational microlensing surveys, where telescopes detect rogue planets. By the way, they temporarily bend the light of distant stars. Observations from the OGL, Optical Gravitational Lensing Experiment, and MOA, microlensing observations in astrophysics, surveys have found several rogue planets, including some roughly the size of Earth. But detecting these planets is extremely difficult. Because they don't emit light, they can only be spotted when they happen to pass in front of a distant star. That means we've likely only scratched the surface of how many are really out there. If these estimates are correct, rogue planets may be more common than stars themselves. But could one of them ever enter our solar system? Could a rogue planet one day drift too close to Earth? With billions of rogue planets drifting through space, could one of them ever collide with our solar system? The short answer is yes, but it's extremely unlikely. Most rogue planets wander through the vast emptiness between stars, meaning the chances of one crossing paths with our solar system are incredibly low. However, astronomers believe it's possible that in the distant past, a rogue planet may have passed near our solar system, subtly affecting the orbits of planets and asteroids. Some scientists speculate that the mysterious Planet 9, a yet undiscovered planet that may exist beyond Neptune, could actually be a captured rogue planet. If true, this would mean that rogue planets don't just pass through solar systems. They can sometimes get trapped by a star's gravity and become part of a planetary system. While the odds of a direct collision with Earth are practically zero, a rogue planet passing too close could still be dangerous. Its gravity could disrupt the orbits of planets, moons, or asteroids, potentially sending debris toward Earth. For now, there's no known rogue planet heading our way, but the universe is vast, and new discoveries are being made all the time. Could there be a massive, unseen rogue planet drifting toward us right now? Rogue planets are some of the most mysterious objects in the universe. Unlike Earth, which orbits the Sun in a stable solar system, these worlds drift endlessly through space, frozen, dark, and alone. We now know that billions, maybe even trillions, of these planets exist, thrown from their home systems by powerful gravitational forces, or possibly even forming alone in the vastness of space. While the chances of one entering our solar system are extremely low, their very existence challenges our understanding of how planets form and evolve. Could there be an Earth-like rogue planet wandering the galaxy right now, hidden in the darkness? Join us next time as we explore more mysteries of the universe.